Hi, scholars. Today is our last day doing applications of circuits. So yesterday we spent the class period diving a little deeper into the relationship between series of the resistors and series and parallel circuits. Today we're going to use those relationships to dive into more complex scenarios and applications of circuits. All right, so for today you are going to need your notebook. You're going to need a calculator. So if you don't have one, make sure to pull up one on your computer, and also your classwork document for today. Our aim for today is to apply our understanding of all the content that we've learned in Unit 6 for solving more complex circuit questions. Okay, so you need to be really, really attentive today and really try to connect everything that we learned so far. If it's helpful for you to pull up your classwork document from yesterday, you can do that as well to help you support what we're going to be doing today. The first thing we're going to start with is our do now. Then we're going to move on to some practice problems. Then we'll go over one of the questions, make sure we're all on the same page, and then we'll just finish the class with practice problems. After that, that will essentially conclude this unit, and tomorrow you will be having an assessment on this. So you'll have another Google quiz that you'll be doing. And again, depending on your teacher, it should be counting as classwork. It depends on your school. Alrighty, so let's start. Before we move on to actually doing problems, there's something that's important that I want you guys to keep in mind. When you're finding the total resistance in the complex circuit, so a complex circuit refers to a circuit like this here. If we look at it, there's a few things going on with the resistors. There is a resistor here in series with the battery, and then over here we see these two resistors that are in parallel with each other. And then here there's another resistor in series. So when you have a combination of series and parallel resistors in one circuit, it's called a complex circuit. So when you have something like this, and you're asked to find what the total resistance in the circuit is, you have to first add the two resistors that are in parallel. Okay, so please make sure to add this into your notes so you can refer to this as we go along. You're going to use this plenty of times today. So then you add these two together, and then if you were to draw the circuit again, it's represented by another resistor now in series with the other two resistors. So then here you would just add these three together like we did yesterday in a few of the examples. So then in this circuit here, my equivalent or total resistance would be this one plus this one plus this one. So it's 2 plus 2 is 4 plus 6. So then the total resistance here would be 10. All right. Again, keep this in mind. Okay, so now we're going to put this into practice. So our do now for today, this is in your classwork document. You're going to have to use your notebook to actually work out the different problems, work out the different quantities, and then type in your answers into the table in your classwork document. The first thing you're going to do is find the total resistance of the circuit, and you'll put this here. And then you just add what the different resistors R1, R2, and R3 are. And that's arbitrary. You can label this one R1, this one R2, and this one R3. And then you're going to find what the total voltage of the circuit is. And that's actually just given by the total voltage of the battery. And then you're going to find what the total current is through the whole circuit. And then what the total current is coming out of the battery, and then what the total current is going through each resistor as well. So remember all the different relationships that you learned yesterday. Okay, so again, it would be helpful if you have either your notes from yesterday or your classwork document from yesterday open so you can refer to the relationships between voltage, current, and resistance in both the series and parallel circuit, because this is now a complex circuit that has both scenarios in one. All right, so take the next 5 minutes to solve this problem, and then once you're ready, you can come back and we'll go over it together. Okay, so you can press pause now. Okay, so let's go through your answers. Okay, so like I was mentioning before, here you should have, I'm just going to move my screen over here. So how you fill this table in, the total resistance, first you need to find the resistance of these two together. So I'm going to do that over here. So the resistors, I'm going to label this guy R1, this is going to be R2, and R3. Because this is a complex circuit, I have to add my two resistors that are in parallel first, and then I'll be able to add it with my other resistor in order to find the total. So 1 over, remember when we're adding resistors in parallel, this is a resistor 2 and 3, so I'm just putting the subscripts there so we can keep track of what we're doing. So 1 over R2 plus 1 over R3 will give me the total resistance there. I'm just going to do it all in one line to save space. So this would be 1 over 10 plus 1 over 15. And then again, the units here are ohms. And then this would be equal to 1 over, I think it was 0.1667. I just put this straight into my calculator. And then remember, because this is 1 over R, then we have to do our cross multiplication to be able to get our answer. So then we have 1 over R23 is equal to 1 over 0.167, just rounding it up. And then I cross multiply and I end up with, again, use your calculator for this, that the total resistance for my circuit 2-3, so I'm going to correct that, is 6 ohms. Right, so this quantity here is 6 ohms for my new resistor. And now I can add R1 and R and this combination of 2-3 together to find what the total resistance is. So the total resistance in my circuit would be R1 plus this circuit combination of resistor combination of 2-3. So this would be 2 ohms plus 6 ohms, which would be a total of 8 ohms. So that is my total resistance. So then in your table, you should have 8. And then don't worry about typing the unit for ohm because it's difficult to find in your, it's in the symbols, so it's fine if you didn't get it. And then so the total is 8. And then I'm filling out the rest of my table anyway with the rest of the information. So this is 2 and this is 10. And then this is 15 ohms. Okay, now my total voltage was 24 volts. Okay, so now that I have, I'm just going to complete the table. Now that I have what my voltage and my resistance are, I can find my total current using Ohm's law. So I'm going to put a line here. So Ohm's law would be V total equals my total current times my total resistance. Sorry about that. I actually had to plug in my computer, so the video might be cut off right there. So I apologize for the technical difficulty. So I have my voltage, my total voltage, total current, and total resistance here. Okay, so far so good. So now I have to solve for my current, right? Because that's what I'm trying to find, the total current here. So like we did yesterday several times, we're going to divide the total voltage divided by the total resistance to find out what my current is. So that is 24 volts divided by 8 ohms. Oh, just happened. Okay, sorry, I zoomed into this without knowing. All right, so I have 24 volts divided by 8 ohms, and so 24 divided by 8 is 3 amps. So this is equal to my total current in the circuit. And so your current value should have been 3 amps. Okay, so now we have to figure out what the voltage is across each resistor and what the current is across each resistor. So yesterday we talked about how when you have a series circuit, the current that goes through a series resistor is equal to the total current in the circuit. So if I have my current going here through 1, has to equal the total current. Okay, so then that tells me that this has to be 3 amps. But then we learned that, so 3 amps cross through here, and now we have to go and see what happens when the current here is going to split, right? And it's not going to split evenly because the resistors are a different value here. So we have to check to see what the total value of the current will be. But first, we're going to use Ohm's law, but we don't know what the voltage going through each one of these is. So we have to measure that. Okay? So let's figure out what the voltage across each one of these is first, so we can determine then what the current is. Okay. So here for resistor 1, I see we have two knowns, and that we have the unknown of voltage. So again, I'm going to put a line here so we can divide our space. We're going to find out what the voltage is here, and then we'll move on to the rest. So if we know the current in the resistor, so then the voltage for the first resistor is going to be R1 times the current through there. So we have our resistance, which is 2 ohms, times my current, which is 3 amps. So then here, the voltage drop across the first resistor is going to be 6 volts. Okay. And so because we learned yesterday that as current goes through the resistors, the voltage is going to drop. And in a series circuit, it will go down just by some amount, not by a total amount. In a parallel circuit, we learned that the voltage drop across both resistors has to be the same. Okay? So if I have 6 volts that went through, that were lost here because of the conservation of energy, the remaining energy is going to be lost to the other 2 resistors. So then all I have to do is subtract the total voltage minus the voltage drop across the first resistor, and that will give me what the voltage across the other 2 resistors are. So it's 24 minus 6 is equal to 18. So 18 volts will be how much potential difference the charges are going to lose once they go through these 2 resistors. So then now I can just put that new value here into my table. So it will be the same for both resistors, okay? But since my voltage is the same here, and then the resistors have a different value, then that means that the current that's going to split between these 2 are going to be different, right? And I had just mentioned that previously. So let's look at finding what the current is for my second resistor. Since I have 2 knowns here, I have my voltage and I have my resistance, I can easily find the current. Again, we're using Ohm's law. And we know that the voltage, based on this relationship that we've used here, the voltage through resistor 2 divided by the resistance of resistor 2 will give me what the current is. So then I have my voltage is 18 volts divided by 10 ohms will give me a current of, so I'm just going to add it here and for the sake of space, it's going to be 1.8 amps. Okay, so now I'm going to add that here. Because of conservation laws, remember the current here has to split, and then at this junction here, the current adds up together. When it adds up, it has to add up back to 3. So that tells me that the current going through resistor 3 has to be 3 minus 1.8 is equal to 1.2. But let's verify that, right? So I'm going to make some space here. Sorry, this is a little messy. Again, make sure you should have been writing this into your notes. I'm sorry that I didn't say it before, but if you haven't done so, once I'm done with this, you can press pause and start taking notes of everything as well. Or you can, rewind the video so that you can write down everything step by step. Okay, so now my current is going to be the voltage going through resistor 3 divided by resistor 3, and that's going to equal to the current going through that resistor. So I have 18 volts divided by 15, and if you divide 18 by 15, you put that in your calculator, and you actually get 1.2. So just as we expected, conservation laws apply, and we see here that the final current is 1.2. Okay, so this was a handful, and this was a lot. I want to make sure that you guys understand what we did here. I'm going to add some additional resource videos for you to watch if you need, because the rest of the problems you're going to be doing are connected to this. And then tomorrow's assessment, there'll be a question like this that you'll also have to solve. Okay, moving along. So now take the next 10 minutes to solve problem 1 and 2. Then come back, we're going to review the answers for problem 1, and then you can move on to problems 3 and 4. Right? Press pause now and come back when you're ready. Okay, let's go over problem 1. So here you're asked, we have Paul has a remote control car and he wants to put headlights on it. He wires 2 light bulbs in series. The wire he used can only tolerate a current of 0.2 amps before getting hot enough to set the insulation on fire, meaning that all the wires that you guys always have like a plastic around them, so that plastic is insulation. So if a wire gets too hot, then that plastic can actually melt, which is could be dangerous. So if both bulbs have a 30 ohm resistance and are connected to one 9-volt battery, will the circuit overheat and justify your answer? So in this question here, we have to try to see, we have to find if the if the current is greater than 0.2 amps. If it's bigger than that, then it's going to overheat and it won't work. But if it's less than that, then the circuit will work properly. So let's see what we have. Let's look and annotate. So we have 2 bulbs that are 30 ohms each, and they're connected in series. And then I have a 9-volt battery. So if you were to draw this into your notebooks, it would look something like this. You have 1 resistor, 2 resistors, and then connected to your battery. Okay, so this is in series. This is my 9-volt battery, then this is resistor 1 that is 30 ohms, and then resistor 2, which is 30 ohms. And now we have to find out what my current is. Okay, and we're going to use that finding Ohm's law. So Ohm's law is V equals IR. Since we're finding current, we're going to divide the resistance by both sides. That will be my current. We know that the voltage is 9 volts, but my resistors here have to be the total resistance. So the total resistance in a series circuit is the easiest one. We just add the 2 together. So the total resistance is just going to be 30 plus 30. So then my total resistance for the circuit is 60 ohms. Right, so then 9 divided by 60, I put this in my handy calculator. 9 divided by 60 is equal to 0.15 amps. So this tells me that 1.15 is less than 0.2. So then this resistor, this circuit will work and it will not overheat. So we're happy. Right, so double check your answers to see if this compares to what you got. And if it doesn't, again, make sure that you write this in your notes so that we can refer to this later as well. Okay. So before we move on to solving problem 3 and 4, I want to help frame, show you how to actually answer this, set up this equation, set up this circuit so that you're successful in solving it. So the question says you have a complex circuit. We have a complex circuit that contains 60-volt battery, followed by a 20 ohm resistor, which is followed by a parallel branch containing 30 ohm and a 40 ohm resistor, and then followed by a 60 ohm resistor. And then you're asked, so that's just the setup of the equation of the question, and you're asked to find certain things. I want to show you how to draw this circuit so that you're able to actually solve for all the different parts that you're being asked. So I have a 60-volt battery, so I'm going to start by drawing that. And then I have a 20 ohm resistor that follows it. Right, so I'm going to label this guy as my 20 ohm resistor. Right, so it just follows, meaning it's connected in series. And then this is followed by a branch that contains a 30 and a 40 ohm resistor. Right, so I'm going to create a parallel branch here like we saw in the previous example. Right, so I'll label this guy 30, and then this one over here will be 40 ohms. All right, so far so good. And then this parallel branch is followed by a 60 ohm resistor. So then I'm just going to add another resistor here, and then I'll finally connect that to my battery. Okay, so it's connected there. So that's how you should consider this problem and then solve the rest. Right? You can, oh, I already have drawn it. So you're going to take the remaining time in class to complete problem three, and then challenge yourself to solve problem number 4. Problem number 4 is kind of hard, but you have the sufficient tools to be able to solve for it. Once you are done, submit your work to Google Classroom, and that is all for today. So I hope you have a fantastic rest of your day, and excited to wrap up circuits, and I'll see you all next time.